Alright, so problem 74, I kind of already did the video, but really kind of sucked. So, you don't have to, you can read this if you want. You could pause it. I won't read it. It's a little long. But a really important thing you have to look at is that the last sentence, or the last two sentences. The engine operates with intake air, weird white squiggly things equal to 1.4 at 25 degrees Celsius and 1 atmospheric pressure. The quantity of fuel injected into the cylinder has a heat of combustion of 1000 joules. So that's like your QH right there. So this is what the diesel thing looks like. This is what your diesel cycle looks like. Just note one of the differences between this and the auto cycle is that here, when the ignition's happening and you have your heat of combustion, it is coming here at the top when you have constant pressure. So an isobaric process in here, it is happening when you are when it is at constant volume. So that's just one of the differences. Again, you could read it if you want. So what we're going to do is we're going to find the pressure, volume, and temperature at each of the four corners of the cycle. So at 1, 2, 3, and 4. And we're going to display the results on the table. So you already know what's at 1. So first you're going to want to convert everything. So you can do conversions right there. Top is volume. Second one is pressure. Third one is Kelvin. We should really all know this by now. I'm sorry. So your first corner, you already know that at 1, your pressure is 1 atmosphere, and like this problem up here says, at 1 atmosphere pressure, you have 25 degrees Celsius, so that's your temperature. And then your volume is also stated right there at the bottom, 1050 cubic centimeters. So you're just going to do all those conversions, and you're going to get that for your first one, for your first column or row in your table. Second one, since it's in adiabatic process, so it's an adiabatic process, you're going to do pressure 1, P1V1 is equal to P2V2. But it's not that simple. Since it's adiabatic, you're going to have to do the y squiggly thing on top, or like n. So P1V1 to the n is equal to P2V2 to the n. In this case, we know that n is going to be equal to the y squiggly. I don't know what it's called, I'm sorry. It's to the air intake, which is a 1.4. So you're just going to use that, and you're going to rearrange the equation. So you're going to get P1V1 over V2, P1V1 squiggly over V2 squiggly is equal to P2. And we already know the volume, because right here the volume is 50 cubic centimeters. So you're just going to plug all that in, and you should get like 7 million whatever pascals after you do all your conversions and everything, which is 7.19 times 10 to the 6 pascals. And you're going to use PV equals nRT to find your temperature at 2. So you can use PIVNER, but notice how when you do that, you have to know what your n value is. Also, please, for this, R has to be 8.13 because of your variables. So n is going to be equal to P1V1 over RT1, because that's the only way that we know all our variables for the. So we're going to use it for the first dot. So you're just going to do that. You're going to get 0.043 mole. So you're going to plug everything in. You're going to get 1006 Kelvin. So when you do everything, that should be what you have for your first table. And here you go for the second one, corner 3. Notice how pressure is constant, so pressure is the same as the last one. P2 is equal to P3. Again, your QH, your heat of combustion, is going to be 1000 joules, as stated right there. Very important to remember that. You're going to get QH is equal to, you're going to do the equation for what QH is, which is NCP, change in temperature. So you're going to just rearrange that to find temperature 3. It's going to be equal to, so T3 is going to be equal to QH over NCP plus second temperature. What is CP? CP is specific heat of constant pressure, which is for a diatomic molecule or air. It's going to be 7/2 times your R value, which is 8.314. So you're going to get 29.1. You're just going to plug everything in, and you're going to get 101805 K, whatever. Your volume is going to be PV equals nRT again. You're going to use your values for your third one, obviously. And then you're going to just rearrange everything. You're going to plug in your values. You're going to get 8.97 times 10 to the 5th. And those should be your final values. And you're going to go down here to the fourth one. You're going to get volume. You're going to have constant volume, as you said. So volume at 4 is equal to volume at 1. So you're just going to do that same thing as 1. Again, since it's a adiabatic process from 3 to 4, you're going to have to do P3V3 to the weird squiggly thing equals P4V4 to the weird squiggly thing, which again is 1.4, as you should remember from there. So you're just going to rearrange to get P4, and you're going to plug in your values. You're going to get that big number for your pascals, so 229,500 pascals. It's equal to your third pressure. You're going to use PV equals nRT yet again to find your temperature. You're just going to plug in your values. You're going to get 674 Kelvin. So how is it different from these two cycles? So you're going to get the Carnot cycle. So it's basically like the steps. So first of all, Carnot cycle obviously is like your most efficient, whatever. So you'll get composition, isothermal. You get you'll do isothermal compression from 1 to 2, adiabatic compression from 2 to 3, isothermal from expansion from 3 to 4, and adiabatic expansion from 4 to 1. Again here, it's going to be adiabatic compression, then isobaric expansion, and then adiabatic expansion, and then isochloric. That's basically your differences. I know this video kind of went a little over, but hopefully this is better than the other video I had submitted earlier. So yeah, anything tricky, just remembering that for adiabatic process, you have to include the V to the N when you're finding P1V1 equals P2V2. That's kind of it. If you have a diesel truck, then this problem is for you because it's diesel cycle, no spark plugs.